Alright, draft physics video. Not the best timing for one, but what the hell. Don't have time later. So, it's going to have to be now. So, Holiday made a couple of stupid comments, and he posted a link to whatever the cowboy is, to a video he made, and it's just a waste of 4 minutes where he thinks he's rebutting something with no rebuttal. So there was only 2 points he brought up. One of them was that somehow I cheated by bringing up the fact that the European LIGO thing has blind spots, and he didn't quote anything I actually said that was in any way wrong. All I said is they're not telling us, they're not showing us exactly how they calculated their blind spot in this case. I mean, how close to a blind spot was it? Was it right in the middle of the blind spot, like right between the triangle? I mean, where exactly in the blind spot was it? And I'm just saying we didn't have that information, so that's all I said. I didn't make any other statement that was at all important. So again, just this, this overt lying in the sense that these people are too cowardly to quote me and then make an argument, and they just imply that I said something I didn't. I didn't say anything. I just said, well, they didn't get a signal, and we don't have any information about why they didn't get a signal. So anyway, so beyond that, the second part was this trial part where I say, that's what this should be. That science should earn it. They should have to go to trial and earn their victory. And he just brought up somehow that lawyers aren't looking for the truth. And, well, that's not the point. That's not even the point of the legal system. I mean, I would prefer to have a legal system where the lawyers actually had to be honest. I'd prefer that. Have a rule that they actually have to be honest. But it clearly works without it, just because you have two sides that are, trying to bend the facts, and there's two sides trying to stop them from bending the facts aggressively. And the judge sits there and watches and says, yes, show me the evidence. Test it in front of me. And that's what happens. They test the evidence. So what exactly is wrong with that? And if you think that's wrong, then what do you think they should do in trials? Because if it's not good enough to decide whether somebody goes to prison for 50 years, then maybe we need some better system. So I'm just saying, which system would you put in its place? Which system is better than proving something beyond a reasonable doubt, or establishing or testing evidence? What's wrong with testing evidence? So again, his point was incomprehensible in the sense that he's basically just saying science shouldn't be tested. Why shouldn't it? Even by people who have bad motives. Why are they afraid of the test? Their evidence should be strong enough that they can survive the testing. You certainly think I should be tested. You think I should be harangued by these details. Why shouldn't they? So anyway, so I deleted the link because it's not a counter-argument of any kind. It doesn't quote me, and it doesn't counter-argue with anything that is at all meaningful as evidence. Alright, so then this Petros Adamorphous guy says, I haven't read all this crap, but it's crap. What bursts of gravity? Well, obviously these gravitational waves travel a long way through space, blah, 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 blah. Highly energetic, made of 3 solar masses in the first case. Lots and lots of energy, idiot. So I think it's legitimate to call something that equals 3 solar masses released in 1 millisecond. I think it's legitimate to call that a burst. Idiot. There are oscillations of space. Well, that means absolutely nothing. Clearly gravity's a force. You want to play some idiotic game that it's space force. I don't really care. Point is, it is something that travels, and it travels at the speed of light. So you can play all your little spacey, warpy games, but it doesn't mean anything. It's an actual thing. It's an event that takes place. Things actually accelerate at a rate, as Holiday points out in a comment. They do it at a rate. It's a process. So you have to account for the process. And we're talking about how this process of creating gravity that can be felt 120 light years away. Okay. There are oscillations in space. Think of sound wave. No, I'm not going to do that. It's not sound, idiot. Light isn't sound either. Newsflash. Anyway, accelerating mass produces GWs. So, says you. I mean, there's absolutely no evidence that there's any waves created. Any on, off signal. Nothing like that. No 3,000 cycles per every 100 seconds. No evidence that any such thing is produced. So that's just rubbish as a comment. Just like accelerating charge produces EM waves. It's nothing like that. There is no accelerating charge principle here. There's no... Are you making the argument that as I accelerate a mass, the mass is actually producing energy perpendicularly? It certainly can't produce it forward. So the only thing it can do is produce less force forward. So if that's the argument you want to make, thank you. That's my argument. You're proving my case in that case. But that certainly has nothing to do with what they're describing. The waves are clearly coming out of the back end of the objects moving. That's how they're drawn. That's how it's animated by the National Science Foundation, their own animation. So you want to go correct them and tell them they're doing it wrong, they're drawing it wrong, then go ahead and do that. But don't make statements you defend with no sources. So give me a source for this mush you're typing. Alright, just like sound is not wind, well, that makes a lot of sense. It doesn't blow air out. Well, whatever. Gravity waves are not gravity. Says you. Okay, show me a source for that. Then what are they? Idiot. They don't attract nor repel. Again, that makes absolutely no sense. So you destroyed 3 solar masses and converted into nothing. That's your argument. A non-force. And by not attracting and not repelling, somehow the Earth got moved. So without using the force of a repulsion or attraction, somehow matter moved. Yeah, I don't think so. What you mean is that assuming your model, this makes no sense. No, assuming their own model. I haven't argued my model with this at all. Okay, I'm arguing their own science. I'm arguing the fact that if I play their press conference, which, I played 1 minute of it, and the woman starts talking about how this validates Einstein's predictions, which it doesn't, which is just an overt lie. So she starts her presentation with a grotesque lie that somehow Einstein said this was happening or could happen, when that's not what Einstein did at all. So, fuck you. Anyway, and you are absolutely right, then it doesn't. Well, I'm just saying by their own model, it doesn't make sense. Einstein didn't think it made sense. Well, if he was alive today, he'd say, that's nothing I included in my theory, you people. You were just making that shit up. Okay, so then there's another next comment. So I'll delete the ones I respond to. No gamma rays or X-rays or anything else produced in any bursty way. So he's quoting me. Yes, that's during the event. While the two things are expelling their mass, while they're converting mass into space, as you would say, somehow they're not producing anything else. A gamma ray burst was observed. Yes, 1.7 seconds after everything had stopped moving. So 1.7 seconds after the event had just stopped, all of a sudden light gamma rays. What's the difference in the speed? Jeez. So I guess they're now proved that gravity moves just a little tiny bit faster than light. Right? Does it somehow took the light longer to get here? Let's see. A gamma ray burst was observed. That's the whole point. Yes, my whole point was, as I pointed out, the point was clearly made in the video. The gamma ray burst happened 1.7 seconds after the event was over. The space creation had ended. Okay. next comment. Gravitational wave strength diminishes linearly with distance. It's not 1 over r squared, it's just 1 over r. Yes, and that's exactly my point. If that's true, then they're saying the gravity waves are produced on a plane. Just this plane. So you can do the r thing when you're just on a plane. That is, you don't go this way, you don't go this way. Nothing produced this way, nothing produced this way, then it's r. Okay? Now, if I tilt the thing producing the waves at 30 degrees, you can clearly see, then how are they going to get to the camera? See? They're going this way. They can't get to you. They're going this way. They can't get to you. So they'd have to still be going r squared for them to get to them. Right? Come on. Oh, I'm sorry. You can't answer for some reason. Yeah, so that's exactly my point. So if you're saying it's r, then you're accepting that it's on a plane. Considering this, the strength of the strength in the vicinity isn't remarkable at all. Well, that's idiotic. Anything where that plane is pointed is going to get annihilated, and it's going to get more annihilated, just like a laser beam takes light and confines it to a space and makes it much more intense. The same thing would be happening. All the intensity of the r squared thing is getting narrowed to a single plane. So now you have 3 solar masses on just a single plane. It's not going the whole light bulb thing anymore. It's doing the laser beam thing now. So anything on that plane, anything that plane can see, anything can see along that linear plane would get annihilated. Okay. This is not all by convenience, says you. The math says so. What math? Again, what math says you can convert mass into space? Show me the mathematical theory, show me the test, show me the evidence where that ever was theorized to be possible, and certainly show me where Einstein said that was possible. It was saying so at a time when everybody knew with certainty that GWs would be forever unobserved because the effect is so weak. Yes, because they had no concept that they were converting matter into gravity waves. When you convert 3 solar masses into something, that's not going to be weak, asshole, especially when you do all of the conversion in a split second. All of the energy released in a split second. That could never be called something weak. And clearly Einstein wasn't considering that. He was just considering, if 2 bodies are moving around each other, are we going to be able to see the little subtle changes in gravity between this and this? Little tiny subtle change in the gravity. And he's concluded quite logically, no chance. Anyway, but then we took some time, who's we, asshole? Invented lasers, computers, interferometry. That was invented quite a long time ago. And the whole idea of the beam splitter is also, hasn't been tested. And discovered that neutron stars and black holes actually exist out there. Well, I'm just saying your evidence is weak. Now you want to declare it true, go ahead, that's your prerogative, but you're no better than a religious person who says, well, I prayed to an apple and I called it Mary, and I said, please Mary, save my mommy, and my mommy was cured. So if that's the kind of evidence you want to believe in shit, well, that's fine. But that's, in my opinion, that ain't nearly good enough. You're a silly person, in my opinion. Alright, and we also noticed GRBs. So you can't write like what the fuck he's talking about. Gravitational what? Red bimbos? Ready bimbos? That we thought were only possible to produce by the latter when they merge. So we built LIGO because we thought, so we built it, his group built it, because we thought the signal was within reach of our best instruments and techniques. Yet, in this one that you've discovered, these two neutron stars colliding, they have no clue what was produced. No guess. Either a super light black hole or a super heavy neutron star. Two things they never saw before, and they, but they don't have any better guess than that. It's either the thing that doesn't happen or the thing that doesn't happen, and that's their best guess. So that's how much they knew about what the fuck they were doing beforehand. Fuck you. Not a good argument. Alright, so which thing should do first? I guess I'll do the original Hoffaday comment before I do the velocity one. So he says, the theory is not that matter is being converted into gravitational waves. So, they overtly say it, but that's not the theory. Okay? The energy of momentum is... exclamation point, from super high orbital velocities to stationary, stupid. So, I commented back, but dumbass, the facts are that when they start receiving the wave signal, the objects are in the process of speeding up, not slowing down. How exactly does acceleration convert mass into gravitational waves? And then I point out waves traveling in the opposite direction of the motion. The sudden stop is not what they were hearing for 100 seconds, you insufferable, patronizing, stupid fuck. So anyway, so somehow he's saying that just merely accelerating is, again, like the other guy, is somehow you're creating waves, that is on-off gravity, some kind of blipping gravity, just by accelerating. Now that can't happen. Now you can argue that So they draw it with the gravity coming out of the tail end. So as the thing's spinning, they animate it as if the gravity is, the wave is coming out of the back end of the thing as it's spinning. So let's just say there was a face to where the gravity came out. I'm still going to argue that there's two questions. Is it coming out on one plane, or is it coming out as much as most gravity does? So when two gravitational things move into each other, what creates the r² thing is that it isn't a direct communication. So when this thing says, I accelerated, I absorbed energy going this way, and that energy is not going to hit you over here. The response isn't that this thing gets all the gravity. The point is that it absorbs acceleration in any one of these directions that just have a component in this axis. So it's that whole XYZ thing. If there's any component in this x-axis between the two things, that counts as motion towards the thing. So that's the inverse square law part of it. The gravity you create by moving, accelerating towards something, you absorb energy. So it can't be acceleration from outer space, or acceleration from a gun, or acceleration from some other thing. It has to be acceleration from the actual gravity of the other body. So once you accelerate towards something, that means you absorbed energy that would have hit here but can't now. And that's Einstein's theory, basically. But the point is that when the two bodies are moving towards each other, they're emitting gravity in that whole face. So it's like two suns looking at each other and where the light hits, sort of. And you have to think about it in that way. If they sent the signal directly back and forth, then it would just be R. And if it was directly back and forth, it would just be, there would be nothing to diminish the force. It would be really, really powerful, because none of it would be wasted creating shortages in all these other locations. So the reason why it's an inverse square law is because most of the gravity you create by accelerating ends up being felt by something in all these other locations. So the gravity you're falling into isn't the gravity you create. It's the gravity created by the stuff on the earth that's still accelerating. So if you fall, free fall, you're free falling into gravity created by other things. Yes, you're going to be creating gravity too, but you're really not falling into the gravity you created, as it turns out. So Yeah, so that's the question to ask about this gravitational wave. If we're going to say it's on a plane, so it's the two things are spinning this way, all right? This thing and this thing, they're spinning this way. And if the waves are coming out this way and this way and this way, and they're thin, okay, yeah, then that's an R. But it's really powerful for anything in that R. But then you can't tilt it. If you tilt that, it can't hit us. So it really can't be part of their theory, because they wouldn't have seen the wave then. So the wave must be coming out in the inverse square. It must be coming out of the entire plane that faces that way. And as it's spinning, it's got to be going out in that, it's like a light bulb. It's going in all directions from this thing except backwards. So it's going this way. Now the trick with that is, that's the opposite of acceleration. For the force to go this way would be the wrong direction, because the absorption took place going towards the other object. So when you're really seeing the stuff, they should draw it with it coming out the front end of it, and it goes right through the other end. It goes right through the other body. But those are the light ends. The light ends are the ends facing each other, towards each other. That's where the energy is being absorbed, is towards the center of the two things' gravity. So if you take the two things and put a center in between them, that's where the gravity is heading. Alright. So if they're creating a wave, they're creating it that way, forward. Not out of their back end, but out of their front end. And the difference is, if it's coming out of the front end, again, is each cycle is only 180 degrees of rotation. I mean, each wavelength only has 180 degrees of rotation, because there's two sources creating it. They're both lit, so to speak. It would be like a neutron star, a binary neutron star, in a system where both of them were lit. You wouldn't be able to see the blink anymore. Okay, well, I don't know how deep into that shit to get, but anyway. So, yeah, fuck you, Holiday, in that comment. Alright, so then this is one of his niggly, nitpicky things, but it is an interesting subject. You don't travel 10 meters in 1 second under gravitational acceleration. Is less if you are moving from rest, dummy. Okay, I would argue it really doesn't matter whether you're at rest. He's basically just saying that the distance you go is really, the 10 meters per second is just the speed you're going after 1 second. So after 1 second you're going that speed, but it took you a while to get up to that speed. It took you 1 second exactly. So you only travel 5 meters in distance, even though you're going 10 meters per second. So in 1 second, in the first second, you only travel 5 meters. Now the trick is, in the next second, okay, you're going to end up going, you're already going 10 meters per second. Your acceleration is, you're already up now to 10 meters per second. And now you're going to be accelerating to 20 meters per second by the time you get to the second second. So in the second second, you're going to travel 15 meters. You see, so now you made up for the meters you lost. It's that kind of thing. You're going to end up making up for the ones you lost, because your speed is going to keep increasing. And so it's basically 22. I did look it up. It's pretty accurate. My memory was 22 miles an hour is what you're going. So after the first second, you're going 22 miles an hour. You haven't been going 22 miles an hour the whole time through that second. It's only when you finally get to 1 second, that's how fast you're going after 1 second. It's 22 miles a second. But you didn't travel 22 miles, so to speak, in this 22 miles an hour, sorry, miles a second. 22 miles an hour is equivalent to 10 meters per second. So it just goes 22, and then after the second second you're going 44, and after the third second you're going 66, and after the fourth second you're going 88, that kind of thing. And so the distance gets to be more later, because you're going 80 miles an hour, and so now you're really eating up territory. Going 80 miles an hour, you're chewing up 40 meters per second. Even though your acceleration is only 10 meters per second, you're eating up 80 meters per second in speed. So as you go further into your, as you go further seconds into the acceleration, you consume distance at a much higher rate. All right. Anyway, so yes, the point's taken. You can't really think about the acceleration and distance in the same sentence, because your acceleration, just like we're accelerating now, and we're not covering any distance. I'm moving zero distance, because my acceleration, although it's real, it's constantly eaten up by an opposite reaction thing, where I go where I'm getting pushed back by the earth saying, nope, can't accept your acceleration, so you're going to have to not accelerate. And so I can never go faster. I can't get any momentum going. So I never get up to 80 miles an hour. I'm just constantly being pushed 10 meters per second per second. It's constantly trying to get me up to 22 miles an hour, but it just can't get me moving. Anyway, so I say, assuming a frictionless circumstance, no wings or feathers, how much less? Shit for brain. And he says, half less. Oh, Dumbo. Let's see. And then, and that would have to be true for all subsequent accelerations, correct? So I was just pointing out that the same obstacle is always going to exist, in terms of that you're never going as fast as you are. You can't go at the end of your second, when the second started, you can't be going as fast as you're going after the second is over. So obviously the mass that isn't, it still takes, you still don't go as fast. You still don't, you always are just accelerating that 5 meter thing. The new acceleration will always end up just being 5 meters, even though your velocity will increase. Your capacity to add distance, technically, will only increase in 5 meter increments. Yeah, I don't know exactly how to say that any other way, but it's probably a better way to say it. So gravity on Earth is only really 5 meters per second. And technically it sort of is, but there's a big difference between how much distance you travel and how much velocity you acquire. So while you keep adding velocity through the acceleration, is where there's an obvious, you can't follow it anymore. You can't separate your acceleration from your added velocity, which ends up being substantial. So your added velocity is the thing that becomes your dominant motion, and the little bit of extra acceleration you're getting is minor compared to the acquired velocity from the previous seconds of acceleration. Anyway. Alright, so then somebody asked him, do you travel 10 meters in 1 second if you are moving from rest? Answer it, you evasive jackass. And so he says, no. The full formula is d equals v1 times whatever t plus 1/2 x times acceleration times t squared, I guess, where v1 is the initial velocity. Yes, and so it just really doesn't matter what your initial velocity is, because adding will always mean the same thing. That is, you have to push whatever's not, technically not moving inside of you. You still have to push the stuff that's not cooperating. Anyway, after 1 second you're at 20, and so on. Okay, so after 1 second you go 10 meters per second. After another second you go 20, and so on. Yes, so if you just convert to miles per hour, you're going 22 miles per hour after the first second, but you didn't go the 10 meters that would mean if you were going 22 miles an hour already. So you start off going 0 miles an hour, then you go 1 mile an hour, then you go 2 miles an hour, then you go 3, and you get up to 22 miles an hour in 1 second. So in 1 second you get to 22 miles an hour, but for that whole time you were going much slower than 22 miles per second. Half. It makes sense. Half makes sense, right? cut it in half, because half the time you were above the halfway point heading towards 22 and half the time you were below. So half would make sense. Alright, so anyway, I think that's enough minutia. But it's a good point to bring up, because there is a difference between, I always did the 10-meter thing just as a shorthand, but I always kind of thought of it as being, that can't quite be right, because I've fallen off a few roofs and it takes longer. I mean, 5 meters does seem like a second, so that makes sense. Yeah, because going 10 meters in 1 second, you really would have to be going awfully fast to go. 10 meters is kind of a good distance in 1 second, so it sort of makes sense. This isn't pool balls. I mean, it's not kinetic. Gravity has to go through you at a rate, and that's sort of the interesting thing. I mean, maybe the half thing is kind of gives evidence to how much gravity, the probability of gravity hitting, producing movement, and it just doesn't do it like a cue ball hitting a 8 ball. It just doesn't transfer the energy completely in a millisecond. It has to transfer the energy through the raindrop principle, or the stream principle, or some other flow kind of principle. Not everything hitting you principle. Okay, so I think that's it for the stuff that needs stuff that was obnoxious. Let's see. Somebody, I don't know, this doesn't even make sense. So there are more arrows pushing our solar system out than arrows pushing it in. It doesn't even make sense. It's always a push from the outside, asshole. So it's just stupid. Hence expansion. So what is dark energy? Whatever. Dark energy is bullshit. That's what it is. Not being a smartass. Just keen to learn. Thanks. Sorry, universe, not solar system. I don't know what you're talking about. Consider the universe a bubble, and consider there's a bunch of loose BBs, and they bounce off the inside of the bubble. So no matter what goes out, it always comes back in. That's pressure. If you were in there, you would feel the BBs hitting you, even though they were going away from you. Eventually they're going to come back and hit you. Eventually every BB will hit you. Yeah, think of it that way. The pressure's always from the outside in. Well, not always, but it always starts that way. I don't know how else to say it. It starts that way. Stuff gets caught inside, for very long periods of time. Just going from one side of the universe to the other side of the universe could take you forever, because you can get caught up in lots of reflections, echoey kind of thing. You're bouncing all over the fucking place. Alright, so Parapologic guy says, it might be worthwhile to give commentary on the discussion video produced by the National Science Foundation's channel. Yes, it's 2 hours, and I'm like, oh, I just know it's going to, I can only get through the first like 60 seconds, and so I really want to do that, but I want to watch it first, and then just play the important parts, right? I mean, you can't just do a 2-hour video. That'll take forever, 6 hours. But I couldn't get through the beginning. I mean, as soon as they start doing this crap that this validates Einstein, it just pisses me off that they can take Einstein. I don't even like Einstein's theory, but I liked Einstein enough to say, this is such bullshit for them to take his name and smear it on their bullshit. To claim ownership of Einstein's mind. That's so obnoxious. They just shouldn't be allowed to do that. When Einstein didn't validate what they're talking about, he didn't. His general relativity and special relativity, neither theory has a damn thing to do with this wave crap. Gravity waves. Nothing. They're just, It's just disgusting that they can steal his reputation and name and pin it on this crap. They shouldn't be allowed to do that. It's just so fucking obnoxious. And even more disgusting, this is the National Science Foundation's YouTube channel, and they had a damn commercial on it. And you're saying, what the fuck is that? I mean, how does that even pass ethical muster? The government's going to pay an advertiser, and they get paid by the advertiser? So what is this crap? The National Science Foundation, with all of its brilliant physicists and smart people, can't even produce a YouTube channel without giving it to some shyster who's putting commercials on it? I mean, what's the deal? Who's getting the money from the fucking commercials? What the fuck are they doing on that fucking website? I mean, that's just wrong. Wrong. It's fundamentally wrong. You know. So, I mean, can you imagine a congressman putting ads on his fucking YouTube channel? I mean, what the fuck is this shit? This is amazing. So anyway, that's probably enough. Let's see. Yeah, somebody just posted a comment. Wow, you are special. Ha ha ha. Because I was talking about things being special a lot in that video. But, yeah, it's not a real biting comment, but anyway, whatever. So, continuing. Moving on. Next. So we'll see. I don't know when I'll get back to this. You know, might be tomorrow, might be tonight. Yeah, I just don't know when I'm going to be able to watch the Science Foundation video, because that's just, it just smells like it's going to be the most irritating thing ever. Just one pile of shit after another pile of shit.